Okay, last problem says use a graph to solve the given system of inequalities. Use Desmos to help you graph the functions and copy down the graph carefully. Shade your solution regions. Test a point to prove your solution regions are correct. You could use Desmos to help you here. You still need to shade correctly and pick a point in the solution region to plug back into the two inequalities and verify that it works for both. I'm going to do this by hand. So I'm going to start by graphing these two inequalities. Let's see, we'll graph this one first. Y is less than or equal to 1/2 x plus 3. Okay. When I graph this, first I need to graph its boundary and then shade. So its boundary is just going to be the equation y equals 1/2 x plus 3. Okay, 1/2 x plus 3, that's a y-intercept at 3, slope of 1/2. So if we're imagining slope triangles, here I am going up 1 unit and over 2. Okay, like this. Because of the less than or equal to, this is going to be a solid boundary line. Okay, so we'll connect these points with a solid line, not a dashed line. Okay, now let's figure out how to shade this. So we'll pick 0, 0 to test. If 0, 0 works, then we're shading where 0, 0 is, everything below the line. If it doesn't work, we're going to shade above. So 0 is less than or equal to 1/2 times 0 plus 3. Okay, that simplifies to 0 is less than or equal to 3, which is true. So we're going to shade towards 0, 0. So everything below the line. Okay, now let's graph this other inequality. Y is greater than or equal to x plus 1 squared minus 2. Its boundary is going to be the equation y equals x plus 1 squared minus 2. This is going to be a parabola. This is in graphing form, so it's going to be kind of easy for us to graph. Because it's in graphing form, I know that my vertex is going to be -1, -2, which is right here. And then if you plug in 0 for x, you're going to get a y-intercept at -1. Okay, plug in some more x values if you'd like to get some more points on this parabola. And then this is also going to be a solid boundary because of the greater than or equal to. Okay, so this is going to look like this. How are we going to shade this? Let's test a point. I'm going to pick 0, 0 again. It lies on the inside of the parabola, so if it works, I'm going to shade the inside. If it doesn't, we'll shade the outside. Okay, so we've got 0 is greater than or equal to 0 plus 1 squared minus 2. All right, 0 is greater than or equal to -1. That works. So we are going to be shading the inside of the parabola. And before we move on to talk about the solution region, here's a little shortcut. Because this was less than or equal to, I should be shading below the boundary. Notice that we are shading below this line. Okay. For the other inequality, y is greater than or equal to, because of the greater than, I know I should be shading upwards. Notice that in regards to the parabola, we are shading above the parabola, okay, not below it. So that works for, this works for less than and then less than or equal to. This works for greater than or equal to. So if it helps you at all, You're welcome to use this. Make sure that you still test your solution, that you test a point in your solution region to check that you've done this correctly, but little shortcut there. Anyway, what we've done is we've graphed, we've shaded our solution region. It's this overlap right here. Okay, this is the solution region. And then the last thing that we need to do is to test a point to prove that the solution region is correct. Technically, we did that already with 0, 0. Okay, 0, 0 does work for both inequalities, but let's say it hadn't. Let's say 0, 0 did not work for this second inequality, and 0, 0 made the statement false, and we had to shade outside of the parabola. We would want to pick another point in the solution region to test that it works. So there's no harm in doing that. Just for another point, I'm going to pick the point 1, 0, or excuse me, 0, 1. And since it's in the solution region, what I want to see is that it makes both inequalities true. So let's just do that very quickly. Okay, so plugging in 0 for x, 1 for y. Again, we've already shaded. We already know where the solution region is. We're just proving that points in the solution region make both inequalities true. Because that's the definition of a solution to a system of inequalities. Okay, so 1 for y, 0 for x. This simplifies to 1 is less than or equal to 3, which works. Okay, 0 plus 1 is 1, 1 squared is 1, 1 minus 2 is, oops, 1 minus 2 is negative 1. Okay, 1 is greater than or equal to negative 1, so this also works. Okay, so any point in the solution region, okay, in this case we tested 0, 1, and we also saw that 0, 0 works. Any point in the solution region should make both inequalities true. Okay, if you picked a point and you plugged it into both and it didn't make one of them true or it didn't make both true, double check your work, because it should. Okay, and that's it.